Based on information coming from astronomers, they have discovered colliding neutron stars that may have formed a magnetar. A recent stellar flash that they saw may have signaled the birth of a highly magnetic spinning stellar corpse. A burst of gamma-ray light from another galaxy would indicate that colliding neutron stars are producing a magnetar. An astonishingly brilliant cosmic blast may have contributed to the birth of a magnetar. If this is the case, it would mean that this is the first time that astronomers have been able to observe a formation of this kind, showcasing a rapidly spinning, extremely magnetized stellar corpse. Dazzling flash of light was made when two neutron stars collided and merged into one massive object. Especially brilliant light may also mean that a magnetar was produced. According to the astrophysicist and his colleagues, they first spotted the site of the neutron star crash as a burst of gamma-ray light, which was detected with NASA's orbiting Neil Gehrels Swift Observatory on May 22. Follow-up observations in X-ray, visible and infrared wavelengths of light indicated that the gamma rays were accompanied by a characteristic glow called a kilonova. Kilonovas are theorized to be formed after two neutron stars. The ultra-dense cores of dead stars collide and merge. This merger between the ultra-dense cores of dead stars causes a spray of neutron-rich material, which is not identifiable or easily found anywhere else in the universe around the collision site. According to this scientist, the material quickly produces unstable, heavy elements, and these elements will eventually decay, causing the neutron cloud to be heated and making it glow in optical and infrared light. Astronomers also believe that kilonovas form every time a pair of neutron stars merge, but mergers produce other brighter light as well, which can swamp the kilonova's signal. As a result, astronomers have seen only one definitive kilonova before, in August 2017. However, they have observed other potential candidates. The glow that was seen by the astrophysicist team, however, places 2017 kilonova to shame. It's potentially the most luminous kilonova that they have ever observed. It basically breaks their understanding of the luminosities and brightness that kilonovae are supposed to have. The largest difference in brightness was in infrared light, measured by the Hubble Space Telescope approximately 3 to 16 days after the gamma-ray burst. That light was 10 times as bright as infrared light seen in previous neutron star mergers. That was the real eye-opening moment, and that's when they scrambled to find an explanation. According to the astrophysicists, they had to come up with an extra source of energy that was boosting the kilonova. The explanation was that the crash produced a magnetar, which is a type of neutron star. Normally, when neutron stars merge, the mega neutron star that they produce is too heavy to survive. Almost immediately, the star succumbs to intense gravitational forces and produces a black hole. But if the supermassive neutron star is spinning rapidly and is highly magnetically charged, in other words, it is a magnetar, then it could save itself from collapsing. Both the support of its own rotation and dumping energy, and thus some mass into the surrounding neutron-rich cloud, may keep the star from turning into a black hole. This is the suggestion from the researchers. The extra energy in turn would make the cloud give off more light, the extra infrared glow that the Hubble Space Telescope detected. There are other possible explanations for this brilliant light as well. If the colliding neutron stars produced a black hole, the black hole may have launched a jet of charged plasma moving at nearly the speed of light. The details of how the jet interacts with the neutron-rich material surrounding the collision site may also explain the extra glow coming from the kilonova. If a magnetar was produced, that could tell us something about the stability of neutron stars and how massive they can get. We currently are unaware of the maximum mass of neutron stars, but we do know that in most cases, they would collapse into a black hole after a merger. If a neutron star did survive, it tells us about under what conditions a neutron star can exist. The location of a baby magnetar would be exciting, and it would help in our research. A newborn magnetar that is highly magnetized, highly rotating neutron star that forms from the merger of two neutron stars has never been observed before. But it is agreed that it's too soon to rule out other explanations. What's more, recent computer simulations suggest that it might be difficult to see a newborn magnetar, even if it is formed. According to the researchers, they are not saying that this matter has been settled. Observing how the object's light behaves over the next 4 months to 6 years is critical, and they will be working together to prove whether or not a magnetar was born from the merger of those two neutron stars. Their plans are to keep following up on the mysterious object which exists, and they will also continue to preserve and look at existing and future observatories for a long time. They will be tracking this magnetar until they are old and gray. They will also train additional persons to track this observation. Like, comment, share, and subscribe. Let me know what you think about this exciting discovery from the astrophysicists, the scientists, and the researchers who have been looking at this phenomenon of the collision of two neutron stars. They have been investigating the kilonova and making speculations about the existence of a newborn magnetar. Thanks for watching. Be safe and goodbye.